Okay, switching gears to some completely different set of topics from now on in the next couple of episodes. First topic that we are going to cover is going to be the multi-gigabit revolution. A lot of people are talking about two and a half and 5 gig internet as the next big thing, but our question is: are they really worth the trouble? From various types of flaky cabling issues, overpriced switches, firewalls that not necessarily support it, and whatnot. I'm going to just have a little bit of a chat with these awkward in between bastard childs of the Ethernet standard. And yeah, by the way, spoiler, sometimes gigabit is even better. So let's roll the intro and then let's start chatting about these multi-gigabit revolution, which not is not necessarily something that you're looking for. Okay, Yasmin is gone. He's traveling this week, so you're stuck with me. But never mind. Topic that we're going to cover today is related to something that I've been kind of thinking about for the past couple of months, especially since I upgraded my network slash internet connection to 2 gigabits per second, symmetric, luckily for me. And I had to do a whole bunch of different saltos to kind of get to the point at which I can actually use that Ethernet connection. And I'm still waiting for at least one more device to have the ecosystem completely ready. And I'm going to talk about some of my experiences with this transition process, and those experiences haven't been all that comfortable or very good to describe. So there will be some bashing and negativity and a bit of ranting as well, but it is what it is. Sometimes when you go with mid standards instead of the actual standards that you know and have used for a long time, it's what happens. So the first real issue that I encountered is related to cabling. That's simple enough. Some of these N-based standards, as we call them, basically promise a very smooth transition from the world of gigabit Ethernet into 2 and 5G or 5G over existing 5 Cat 5e or Category 6 cables. If you're lucky enough to live in a building that's recently built enough so that you actually have those Cat 6 cables, which mostly people don't. And they can support these speeds according to the standards to something like 100 meters. But yeah, that's something that I'm going to be kind of like dispensing with in the first couple of minutes of me chatting about this. The problem with this is the fact that the real world is not a testing lab. Testing lab in which they achieve these speeds might really exist, and all of that can be a part of the standard, and all of that is fine and dandy. But in reality, I have partial 5e, partial 6, Cat 6 cabling. 5e is a no-go for in my from my perspective here. In the installation that I have at home, 6 is not a problem. It works. It works with basically 10G as well, so it should be able to do 2.5G, and that's not going to be a problem. But the problem with all of this is that a lot of home installations rely on 10 plus year old installations that are barely meeting the specs for 1G, for 1 gigabit Ethernet, let alone multi, which means if you encounter additional termination problems, patch panels that don't work good, cables that have been, you know, bent in weird ways, mixed category patch cords, and whatnot. All of that can make significant or create significant issues with your desire to move towards the faster standards. And so far, using 5E based cabling has been really unstable for me. So links have been rather unstable and they flap between speeds, constantly switching between gigabit and 2.5 in my use case. And recertifying cabling means testing and possibly repulling the wires, which is what I've partially done in my apartment because I cannot put up with this. I would like to be able to use the new connection as much as possible without, going through the trouble of installing a 30-foot cable from my ISP modem directly to my computer here on the desk so that I can, walk over it and destroy it in a matter of weeks. So, generally speaking, what was supposed to be a little bit of a more painless upgrade experience is more of a slow motion recabling until the reality kicks in and you just decide that you're going to take the necessary tools and do it even yourself if you know how to. And even if that cabling is working okay, the there are some potential issues with crosstalk and physical layer and whatnot, and especially cheaper cables if you're running them. So, reason number two, there's a huge chance that you're going to have to just switch to new cables towards your computer, even if you have a 2.5G, let's say, ISP modem, and then uplink that to a 2.5G Ethernet switch. The last mile cables that are connecting you to your computers might also be something that's a little bit more flaky. It's just something that coincidentally people oftentimes forget. So there's definite installation and upgrade frictions happening here as well. So, in the interest of being a little bit more future proof, installing Cat 6 cables all the way is basically the bare minimum nowadays. I've seen some projects in the uh, building industry happening right now that already started with the Cat 7 cabling, and I don't think that that's such an overkill for the current time frame actually. And the supposed cost savings that you might or might not have with the reuse of the old installations will dissolve very soon. If you need, uh, for example, if you're working in a smaller office and you want to recertify your cables and want to have certification exports and whatnot, that's something that smaller corporate entities are going to have pains with. So yeah, a lot of these different reasons why you might want to consider recabling from the get-go. Then one thing that I actually found to be quite surprising, um, taking a look at some of the devices that I required for this. So I had to buy a stack of new 2.5G switches. I'm in the process of ordering a new firewall that has the capability to run 2.5 and 5 and 10G. These are super expensive. I'm going to show you the price list of 14 devices for that on one of the websites. So it's quite a headache. One of the other problems that I've definitely seen in the past couple of months since I started building out this infrastructure is the fact that there is a completely different set of power requirements, and with that comes heat. If you're working on the premise that you're going to deploy your 2.5G modem and then the switches in some kind of a closed cabinet or something like that, you might want to rethink that strategy from the get-go, because these newer physical connections will consume far more power than 1G, especially if you're using power over internet, for example, for your cameras or something like that. And if you are thinking about using the SFPs, so the optical connections with the optical terminations, yeah, you might want to consider that as well, because they use quite a bit more. They have quite a bit more of a power envelope when compared to the 1G. That's my experience so far, and I've made some measurements, and they reflect what I said. But the heat problem is actually connected to a variety of different other problems that you might encounter here. Um, First and foremost, most of these devices are cooled. They will have active cooling, and that in translation means most commonly they will have fans. And fans, when installed in smaller chassis and cases, whatever they may be, for the networking devices, they tend to produce a lot of noise. So, me being somebody who is very sensitive to different types of sounds, being a musician and all, the noise that comes from these devices is super annoying. That's something that I did not figure out from the get go, so I had to buy different switches to kind of like get back to the sweet spot at which it doesn't annoy me as much. Because literally, with some of the switches that I tried, I could not record the podcast without doing some kind of a additional sound isolation on top of everything that I already have here in my home office. The second side effect is related to power over Ethernet. If you calculate the increased temperature along the cable bundles that are carrying power over Ethernet for all of the efficiency reasons that you might have heard about in the past, basically you're going to get even more heat coming on the central device where you connect it, even more heat coming through the wires, more heat towards your cameras that you're powering or other types of devices that you're powering from that. And all the sum effect of this is rather uncomfortable, actually. I've played around a little bit with one of the PoE cameras that I have here, but just for fun. I don't use those at home or in my home office. And the results were quite a bit different than just using all the regular old school 1G cables. So, ironically speaking, that's kind of a downgrade. Moving forward in the technology stack doesn't necessarily always come with a big, such a sensible, such a, let's say, uh, big difference in some of the side effects that you might be using as a result of the installation of the new technology. So, ironically, it's somewhat of a downgrade as well because you burn more electricity, you generate more heat to achieve incremental throughput improvement that many real workloads will not even notice at the end of the day. That brings me to the topic of pricing. Let's forget about the cables for a second. That's really not that much of a investment in smaller offices and or in apartments. The crux of this discussion is more related to switches, firewalls, SFPs, specialized cables if you have to do optical and whatnot. So let's talk about, let's say, switches first. The pricing of the 2.5 and 5G switches are, let's call them uncomfortable for the purpose of this discussion. They sit at a very weird place in which most of the decent ones are much more expensive than the gigabit Ethernet models, but they are still not cheap enough to undercut the big brother 10G Ethernet, which is now super abundant everywhere around you. You can buy very cheap MikroTik or Netgear 10G switches if you wanted to, even in larger or higher port counts. They are not expensive. They are really a couple of €100 can only buy you a 10G switch, believe it or not. And I'm not talking eBay, I'm talking fresh new ones. If you want a larger number of ports, 5, 6, 700 euros will already get you something like 12 or 16 ports if you know which devices to buy. And that actually has a cascade side effect on many other things downstream. For example, 10G SFPs that have DAC cables, so direct attached copper or optical cables, whatever they may be, they cost significantly less per gigabit. And the switches that support it, as we said, are way more expensive. And at the end of the day, for certain installation situations, you might actually be required to run optical because of the inherent problems with noise and other things that are always present when you're running the copper cables and whatnot. So there are quite a few different things that happen here if you don't have SFP cables or something like that. SFPs, sorry, SFTP cables and stuff like that. So the switches that you might have to buy for this are really awkward in terms of prices. The market gap towards 10G is even more uncomfortable when you really analyze it and whatnot. So it depends. It really remains to be seen whether or not that's a worthwhile investment of your money and time. Generally speaking, for that purpose, I think that 10G is a much better bet. It has basically the same requirements in terms of cables. SFPs are cheaper. DAC cables can be cheaper as well, and that one offers significantly more throughput if there's a situation in which you can actually use it for something, let's say locally in your network. On top of it, these standards are still quite younger than 10G and gigabit Ethernet for that matter as well. So I've encountered some incompatibilities as well between various devices and very unhappy with that because I haven't seen these sorts of situations in quite a while. So I've seen, speed flapping between the modem and the switch, between the switch and the switch as well. So this is something that might be worthwhile in terms of taking under advisement. Then, from the client standpoint, so computers and whatnot, we have even more weirdness there. First problem, a lot of people have laptops. A lot of modern day laptops don't even have like physical network adapters at all, which is something that we already called out many, many times over in this podcast. So it's basically moving forwards by going backwards. Then you're forced to buy, USB Ethernet adapters and whatnot, which is not always something that you want. You don't necessarily want to waste an USB port for running a Ethernet adapter. That's something that's unconscionable to me that laptop manufacturers are doing this, following on Apple's lead and whatnot. And most of the consumer grade 2.5G adapters, they're mostly based on cheaper chips, Realtek's and whatnot. They are really buggy in terms of firmware and drivers. This is something that I found out recently when trying to run 2.5G from a laptop. And especially one of the things that happened to me much more often than I expected was the speed flapping after a laptop has been put to sleep or a computer has been put to sleep. I've seen it on physical computers as well, non-laptop ones, desktop ones. So inconsistent speed negotiation, auto negotiation, power management issues, whatnot, all of that can lead to significantly different experience that you expect. PCI Express cards, on the other hand, are quite a bit better. I've tried a couple of them in my computer, and yeah, that's quite reliable. So that shouldn't be a problem. But still, because of the fact that timeline wise, these are much newer than the 10G standard Ethernet adapters that have been around the block for more than 10 years. I mean, you can buy a two-port Intel's X series 540, 520, whatever, both different models in terms of the copper and or optical connections, whichever you want, on eBay for peanuts nowadays, like 40 euros or so, which coincidentally is roughly the price that you pay for a 2.5G adapter as well. USB adapters for 2.5 tend to be even more expensive if you want to use some kind of a decent branded adapter, not something very cheap. And those network cards, especially Intel ones, I have them in my computers all over the place and in my servers. They're rock solid. They work 24/7, 365, and they're not going to, leave you hanging when you need them the most. So if you're in a situation in which you are not doing it for your, let's say, home, if you're talking about an office that has dozens of connections or whatnot, definitely the 10G makes way more sense. And especially if you go with these types of Intel adapters or whatnot, you're going to be much more happy with both the performance and the long-term stability. I mean, even if the enthusiast builds nowadays sometimes quote, and they mentioned that they did have some problems with the 2.5G adapters. You can find that on the internet and on YouTube as well if you want to check for the videos for basically marginal throughput improvements overall. In a situation in which you are deploying, for example, a 2.5G Ethernet at home, this is a can of worms that has an additional set of worms to add to that, which is wireless. So mostly people do tend to have wireless at home, and most commonly we have it in the office as well. Let's focus on the home installations for a second. A lot of the service provider provided internet access devices don't have wireless access point with that is compatible with the newer, 6 plus standards, whatnot, whatever they may be called. They are capable of doing multi-gigabit over wireless. The problem that's in the background of this is also that you most probably will have to buy such a device, which makes the installation even more expensive. Then you have to be very careful about, yet again, the cables and the switches that you're buying, and then you have to connect it to correct port on the ISP device because ding ding ding, not necessarily all of the ports on the ISP provided, internet access device might support more than a gigabit Ethernet, for example, most commonly. So you're going to be forced to use the SFPs there most commonly. And connecting SFP, so optical connection to a wireless adapter, that's a can of worms you don't want to open, because most commonly you're going to end up with some kind of a media converter. I've been using many different types of these over the years, and they, although they do their job, they tend to fail over time as well. So that's not the most convenient thing that you might want to do, especially in home installations. It's even worse if you're using that in the office. So basically, that kind of makes the idea of 2.5 and 5G kind of pointless in a way, because you're going to have to add two or three additional devices to get what you already have with gigabit Ethernet. And if you don't want to move further than that and you're happy with that, that's cool. But if you go to 10G, there are multiple different available copper-based wireless access points with 10G uplinks on copper, yet again, which you can buy if you are looking for, to squeeze the most amount of throughput and everything from your wireless network that you might be running. So there are more than a few available devices like this. So you might end up in a situation in which you have the service provider provided device. Then you have to connect that via optical cable or a DAC cable to a switch. Then from that switch, you're going to have to connect that to your wireless access point, or even worse, you're going to connect the wireless access point directly to the second port of the provider provided device, which then again is usually SFP, which is going to leave you with the difficult decision usually to buy a media converter. So you're going to have three devices already there, and then then all of the cabling and whatnot you have to do. It's just going to be one big mess. It's very difficult to do that in existing installations. That's the crux of the whole episode, actually. If you are building a new place, you have the freedom to kind of like work with the people who are doing the projects for this, both installation and on paper, and you are willing to pay just a little bit more for Cat 6 or 7 cables, then most of these problems are non existent. But my biggest pet peeve with this idea of 2.5 and 5 gigabit Ethernet, and a problem that quite a few of my colleagues who are IT professionals, let's be honest there, also ran into, is the fact that at the end of the day, in ours, especially small offices, home offices, we mostly want to have some kind of a firewall. The service provider devices don't have decent firewalls, so a lot of people I know have home, just like myself at home, they have Fortinet firewalls. That's one of the really good examples of a very decently priced device in terms of the hardware pricing, and then we can have a debate about the licensing price. But there are some positive sides about this discussion when using Fortinet devices that I'm going to discuss in a second. The problem is the fact that if you want to go with the, let's say, FortiGate, which is Fortinet's firewall, that has 2.5 or 5G connection capability, the probably the cheapest device that's available right now would be, I think, 90 or 91 model. So FortiGate 90G series or something like this. Those devices, so 90 and 91G, are very good. I have their older brother, which is a little bit slower. I've been using it for many years, and before that, I have one, and I have the devices all over the place. Basically, what they have is the 90 and 91G models. They have 8 gigabit Ethernet ports. They have two combined SFP and copper connections for 2.5G. So you can either use the optical connections or the copper ones, which this is what makes these devices so good for smaller environments. If you can afford to buy them, that's the topic that we are yet to discuss. And all of the standard features that it has and whatnot, we don't. This is not an episode about the Fortinet Fortinet as a firewall provider. It's more about the endpoint in your network. So I would be very happy to, and I'm currently seriously considering upgrading to this device so that I can do this end to end, like somebody who actually, connected everything in a correct way. But there is a small itsy bitsy little bit of detail there. So Fortinet FortiGate 90G price. If you go to avfirewalls.com, which is one of the places where a lot of people look for their Fortinet pricing information, soon enough you're going to realize that the 90G, 91G devices are not necessarily within the reach of normal human beings. You know, even for IT professionals, they are not all that cheap. They're 1,500 euros plus easily, and list price is more than $2,000. Now, on one hand, you could happily accept the fact that this device can do everything that you need. It can actually be a, if you want to have the latest wireless, which is insanely expensive, but whatever. The FortiGate devices do have built-in wireless controllers, so you can do that as well as a centralized thing, which works well. But pricing-wise, this is not necessarily something that's going to, endear a lot of people towards the 2.5 or 5G Ethernet because for IT professionals that need to have that faster connection and you have your own stuff that you're working on apart from, watching YouTube videos and downloading torrents. Let's be overzealous there for a second. This is not necessarily going to be an easy sell. The good part of that, which Fortinet has been known for years, is the trade up programs. So if you have some kind of an older Fortinet device that you have been using, you could trade it up for a newer model for a reduced price and then transfer the license from the old one to the new one. I just recently renewed my license 2 months ago in August. So this would make my investment significantly more appealing because it would slash the price by quite a lot, um, while meeting all of the necessary criteria for what would be something like a let's say end-to-end situation in which I could do 2.5, 2.5 G, 5G, and even 10G. So this makes it ready for tomorrow, when I will surely, go towards 10G because that's A, all around me. B, I have more than a few devices already connected via 10G, locally at least, and it's the logical next step. I mean, it's not like I'm going to run 25 gigabit Ethernet at home. It's just unnecessary and overkill. But 10G, that's something that I might consider in the future for storage reasons, primarily because, archiving many, many, many terabytes of our podcast videos and streams and whatnot. Difference between 1G and 10G when you're using it for regular, file copying tends to be quite substantial if the devices can handle it. So in my case, I have a Synology NAS that can handle 10G really well, and yeah, it's 3 to 4 times faster, and sometimes that makes like a very very big difference when you're migrating a lot of data. And in general, that tends to be a reasonable assumption. Uh, this is from the standpoint of somebody who is using this kind of a, let's say, network model and have been using it for many years now. This, again, I bought my Fortinet firewall like 7 or 8 years ago. But all of my customers had it, so I wanted to have it at home. Eight for because it's a firewall and a good one, and B because all of the customers had it, so I wanted to learn how to configure it, and that's paid a lot of dividends in the past 5 or 6 years. So in a sense, moving towards 2.5G or 5G, unless if you are an IT professional, which means that you require some kind of a device like that, perhaps all of the other use cases make it completely moot point upgrading to a newer standard because it just costs way too much to upgrade so that you can do everything that you wanted without sacrificing anything, because it would be stupid to run for example, a part of the network on a gigabit Ethernet behind the old firewall that's gigabit Ethernet, and then have a separate network connection that bypasses the firewall so that I can have 2.5G uplink for, I don't know, for a couple of computers. What's the point of a firewall then? That's completely beside the point. Next reason, I think it's reason number 7 or 8. A real world throughput difference between these standards and 1G are way less than people know. Just as an example, I've done some checking and I've played around with some of the tests. Many tests will only bring you something like 2 gigabits per second on a 5G link. This is something that I've found consistently to be true, even in much more, let's say, reliable testing scenarios in a lab with very good cabling and whatnot than what I have at home. And then if you have a little bit more complex setup, for example, an office setup with VLAN, with firewall inspection and whatnot, this is going to drop significantly, again, depending on the devices that you invested in. So for office type of situation where we have like 10, 20 people or whatnot, this is a very big question mark, especially at the current state of the market in which the devices are quite expensive and you actually have to wait for them for quite a while because yet again, availability of said devices is not necessarily the best. I have at least two more reasons why this is a topic that I'm discussing today and ranting a little bit. Apologize for that. Mostly in the past, whenever we had some kind of a half step in the ecosystem of anything, usually that doesn't work well. So that's a long-term experience that I've been having. Imagine having a situation in which you have a printer that's connected to the network that uses 100 megabit per second interface, which is more common than you think, or a printer that uses 802.11b, yet again, much more common than you think, very slow, 11 megabits per second standard. Then, for example, you have some kind of an older laptop or a desktop computer that only has a gigabit Ethernet. Then you have another computer that's 2.5G. Then, for example, a newer laptop that only has wireless without the Ethernet connection, and you're not inclined to pay way too much money to have a decent 2.5G or 5G external adapter and whatnot. And maybe on top of it, you have a 10G uplink or something like that. That's a lot to ask from basically the equipment that you buy to be as efficient and as cost efficient as possible, which again leads to all of the aforementioned problems that I mentioned so many times. And using additional technologies like said, adding VLANs and doing spanning tree and routing and whatnot is only going to kind of like deepen the problem. So be careful when considering all of this. Put everything on the table. Don't just get seduced by the number. And even forgetting all of these reasons that I just mentioned, I think there were like 9 of them or so. I think the reason number 10 is by far for me the worst. Overall, when you do the calculus of everything that I said in the past half an hour or so, when you put it on a piece of paper, when you calculate everything that you're going to have to do, change the changes that you need to do, the devices, the cards, this, that you need to buy, whatever, and then compare that to 10G, you're quickly going to become very acutely aware of the fact that these half standards are basically very bad return of investment types of situations. They cost all of the adapters and necessary devices way more than gigabit Ethernet devices without offering something like a quantum leap in performance. They're not necessarily future proof. They're really scarcely supported in a lot of different situations. If you really require much more speed from your, let's say, network at home or in a smaller office, literally, buying anything that's 10G is going to make a hell of a lot more sense. Furthermore, in the office situations, you're usually going to have to buy some servers. Servers most commonly nowadays also come with 10G. I don't remember ever seeing a server that has 2.5 or 5G Ethernet connection by default. So that makes it completely a moot point yet again. And the inevitable thing that is going to happen in the future, everybody's going to switch to 10G Ethernet because it's going to become, the bread and butter cheap. From the technology standpoint, if you stick with 2.5 and 5G and buy exclusively devices for that reason, you might just get stuck in the endless loop, and in the next iteration, you might have to buy all of the new devices, which is definitely not the best thing to do. The aforementioned 40 firewalls, FortiGates 90 91 models, are actually a good step forward from that perspective because they support everything I mentioned, gigabit 2.55 10G, so that's good. There are switches out there that support the same thing, but they are not necessarily very widely available. Point A. Point B, they're often not in stock, and C, they cost a little bit more money. And D, you have to be extra careful when you're checking the technical specifications of the switches and read through the documentation to make sure that they actually do support everything that you think they do. Don't chat GPT on this because oftentimes you're not going to get the correct model information. Just as an example, I remember doing a query in ChatGPT a couple of days ago, something like, "What is the cheapest FortiGate 10G device that I can buy?" And it started with FortiGate models 100 plus, 100 series plus, which was not true. So 90 models are the cheapest one currently fully supported that are available that do support the 2.55 and 10. Now, to kind of like go and not necessarily just to wrap this episode up, to kind of like describe why this is important and why I actually decided to go to 2 gigabit Ethernet uplink is related to the use case. In this specific scenario, the use case that I have for 2G Ethernet makes it the viable speed for uplink because that was the fastest connection available. And then obviously from the standpoint on everything that gets connected to that internet connection, obviously I had to upgrade everything and soon enough that will be done so that I can use that speed. I don't download torrents or play around with that stuff, but uploading videos to YouTube, for example, uh, that's something that takes quite a bit of time. Uploading to Rumble, if you're, we also keep our channel there as well. Feel free to contact us there, or of course, feel free to leave a message in the chat box as always. Basically, the use case kind of pointed me in the direction of actually this may being worthwhile. But from the get go, I was firmly in the frame of mind I have to go with something that's 10G compatible because that's the only logical next step. And for me, not only a proven technology, I've worked with 10G Ethernet for a decade now, so I know it works really well. It's more of a, let's say, partial future investment proofing in a sense, because it makes no sense to do things over and over and over and over and over again when you can do them from the correctly from the first get-go. That's something that usually you get pissed off with. You spend way more money and way more time actually if you have to upgrade in that sense. So ultimately, the decision is always going to be up to the person that's deciding there. That's all universal truth. But at the end of the day, you know, uh, to kind of wrap this up now, really, if you don't have the use case that Apple absolutely demands it, that's point one. And point two, if you don't have the necessary, money in the bank to do that, because that will require some, some sorts of hundreds of somethings in the dollars, euros, whatever your denominations may be, maybe even thousands. It really depends on the situation. Please don't do this. For a marginal gain in gaming, this is not a worthwhile investment of your money or time, unless you're old school gamer that is ready to live with one cable going through the living room to his or her computer so that they can have two gigabit Ethernet connection, 2.5 gigabit Ethernet connection to the ISP device so that they can have 2G internet uplink for, a reduction in latency that can be counted as a statistical error. It is what it is. Okay, please feel free to leave us your thoughts in the comment box. I've been veteran. This episode has been a little bit shorter than usual. Just wanted to kind of like get this off my chest because I've been pissed off about this for months now, going through this. Hopefully, you don't mind, and I will see you in the next episode. Bye bye.